All right, welcome everyone. My name is Ahmed Khan. I'm a solutions architect with AWS, and I focus on our machine learning and AI services. So today's webinar is about training machine learning models using TensorFlow on Amazon SageMaker. What we'll cover in this webinar is, first of all, we'll talk about Amazon SageMaker, what it is, how it works. Then we'll move into a question that a lot of our customers ask us is, hey, I'm already running TensorFlow on EC2. Why do I need to run it on SageMaker? So we'll address that. And then we have a couple of demos. We'll be using the Iris dataset to show you how you can train using TensorFlow. And secondly, we'll show you how to deploy once the TensorFlow model has been trained. We'll cap things off by showing you a few resources that help you get started with SageMaker. So we have a lot of content to cover, so let's get right to it. So first thing is, what is Amazon SageMaker, what it is, and how does it work? And so before I dive into that, I want to sort of go over the typical machine learning process. And the machine learning process usually is pretty complex, right? You usually start off with a business problem. For example, if you're at a bank, you're finding out that there are a lot of fraudulent transactions, right? And you want to reduce the number of transactions. So you have to frame that, first of all, as a machine learning problem. So which, in this case, what you're trying to do is given a transaction, you're trying to identify whether that transaction is fraudulent or not. And so first off, you need to collect the data. You need to collect the data about good transactions versus fraudulent transactions. Maybe you need to integrate data from multiple systems. You need to clean it. Once you're done with that, you're probably gonna go into visualizing the data, try and gain some more insight. Maybe the fraudulent transactions happen at a certain time of the day. Maybe they're dependent on the season. Maybe there are more fraudulent transactions during the summer. And so you might want to do some feature engineering. So you break up the transaction date into time of day or the season in the year, right? And so you do some feature engineering and you move into the compute intensive part, which is the model training and the parameter tuning, right? You train the model, then you evaluate it, and if the result is good, then you move on. But if it's not, then you're back to square one. You're collecting more data and you're repeating till you get enough features in there, you get enough insight out of it that your business goals are met. And once they're met, you want to deploy that model. And the story doesn't end there, right? We know that new data is coming in, and so we want to make this into a cycle where new data is added on, and we retrain our model to increase the prediction performance of our model. And so there's a lot going on here, right? As a data scientist or as a developer, you have enough to worry about. You have to really focus in on the machine learning problems, on the algorithm, and really understanding your data better, right? And so anything that adds to that adds to the complexity, even if it's installing and maintaining operating systems and provisioning instances or updating deep learning frameworks, right? And so that kind of distracts you from this cycle, which is already complex. And so at AWS, we provide you with a whole stack of machine learning services. And so first and foremost is our AWS Deep Learning AMI, which is an Amazon machine image. And it comes pre-installed with most of the common and popular deep learning frameworks, including TensorFlow. So using the deep learning army, you can get started very quickly with using any of these deep learning frameworks. Secondly, there are platform services, and there are a couple of them. Amazon Mechanical Turk has been around for a while. It's being used by a lot of our customers for labeling training data, for generating training data. And Amazon SageMaker is the service that we're going to be using today. And so it brings a huge improvement over just using the deep learning army. And so we'll look into how it makes that possible. And so on top of all of this are our application services. And so these are higher level APIs where if you don't have your own custom data and you don't want to train your own custom model, and you're doing common machine learning stuff such as translation from one language to another, or text to speech, or transcribing a voice into text, or detecting common images, common objects within images, you can use some of these higher level services to do that. You really don't have to train a model. You don't even have to know anything about machine learning. These are simple APIs. The higher level application services are simple APIs. And so today we're going to focus on SageMaker, and we're gonna see how you can use SageMaker to train TensorFlow models. So TensorFlow is one of the most popular deep learning frameworks out there. So what is SageMaker in a nutshell? It's a fully managed platform that lets you build, train, and deploy machine learning models at any scale. It takes away the burden of managing any kind of infrastructure, of maintaining any kind of infrastructure, and really removes the undifferentiated heavy lifting from the machine learning life cycle, right? And so if we dive into it a little bit, we'll see that the three phases that I mentioned, the build, train, and deploy, how does SageMaker really help you with that? First off, it provides you with built-in notebook instances, so you can get started very, very quickly. The notebook instances come pre-installed with most of the major deep learning frameworks. Secondly, SageMaker also gives you pre-built algorithms, access to built-in algorithms where you don't have to write a lot of custom code. All you have to do is make sure that your data conforms to a certain format, and you use some of these built-in algorithms and don't have to write a lot of code. So your build cycle is really optimized and accelerated. And if the built-in algorithms are not appropriate for your use case, you can definitely bring in custom code, and you can use most of the popular deep learning frameworks to implement your training code. Once you implement the training code, it's super easy to make a training call and perform distributed training on Amazon SageMaker. Once you have your algorithm defined, a lot of people will then experiment with hyperparameters, and we have a really cool feature within Amazon SageMaker called hyperparameter optimization that actually treats the tuning of the hyperparameters as a machine learning problem itself, and so you don't have to do you don't have to run manual experiments, and really you can automate that phase as well with hyperparameter optimization. So we'll look at that as well in upcoming slides. The final phase is the deploy phase. So once you're sort of satisfied with the performance of your machine learning model, you want to deploy it. And so Amazon SageMaker makes it super easy to deploy a trained model. It creates the API for you. It creates the load balancing layer, and it provisions multiple instances in multiple availability zones, so your endpoint is highly available. And we also offer auto scaling as well, which makes your endpoint super scalable, and it can scale based on the load of traffic. All right, so we'll we'll dive in and let's we'll look at how SageMaker trains and how it interacts with different AWS services. But before I do that, I want to kick off our demo script. So the demo that we'll be showing today is going to take about 5 to 10 minutes to train and then to deploy. And so I already have the notebook instances over here. And so what I want to do is I'll click on open and go over here. This opens up my Jupyter notebook. I can click here and open the notebook itself. All right, so this is our demo notebook. And we'll come back to that, but for now, I just want to kick off the training, so it's all finished and we don't have to wait for it once we come back to it. All right, so let's go ahead and so we've seen that it's starting to train. So we'll come back to this. It will take about 5 to 10 minutes to run through. So let's come back and see how this process works first. And so everything within Amazon SageMaker is implemented on top of Docker containers, right? Both the training jobs and the inference jobs are run within containers. And so what you have is if you write your own training code, that's going to get packaged up into a Docker image, and it's going to reside in Amazon ECR. So there's integration between Amazon SageMaker and ECR, as well as S3 for data. And so and if you don't know about ECR, Amazon ECR is our Elastic Container Registry. It's a private registry for you to store your Docker containers. And so when you start a training job, that Docker container, Docker image is used to launch a container on training instances within Amazon SageMaker, right? So that training code is deployed into a Docker container. And the first thing that it does, it downloads the training data from S3. The training data has to reside in S3, and it is pulled in from S3 using either one of two different modes. There's a file mode and a pipe mode. And so this is a very important point. So I want to actually highlight this. There are two modes. The first one is the file mode, which essentially copies all the data files from S3 onto your training instance volume. The good thing is it works with any supported data format. So if you have your data within CSV, it will support that. But what you need is a lot of disk space on your training instance. The other mode is the pipe mode, which is the more efficient mode, and it streams data directly from S3, which results in faster start times as well as better throughput. One of the advantages is that you don't need that much disk space. You only need enough disk space to store the model artifacts. But one other thing you have to keep in mind is that you have to convert your data into the protobuf record IO format. That's the data format that the pipe mode supports. And so coming back to our SageMaker flow, and so you'll use either the file mode or the pipe mode to bring data into the training instance. And the training job is run, and once it's finished, the model artifacts are then going to be uploaded into a different S3 folder, and the inference code is then packaged up into a Docker image and also posted up on Amazon ECR. Now you're done with the training phase, and it's time to deploy your model. And once you deploy the models, sort of a similar thing happens where the Docker image from Docker inference image is taken in, and a container is launched from that within Amazon SageMaker. And the model artifacts that were previously uploaded to S3 are pulled into the inference code, and we create an endpoint. And this is all transparent to you. You're just specifying the number of instances. A load balancer is automatically provisioned, and your client application can then invoke that inference endpoint. The nice thing is, since the data is all in S3, you can augment your data with new data as it comes in very easily by writing the data into S3. And as you grow the data, once there's enough additional data, you can retrain the model. So once you start going through this cycle, you're going to be iterating your model, and you're going to have multiple versions of the same model. And so within the deployment section of the Amazon SageMaker, it makes it very easy for you to do split testing. So if you have multiple versions, you'd want to test out those versions before you put them into production. And so in this example, we have this model named prod, and we have a few other versions of that model as well that we want to test out. So within Amazon SageMaker, there are a few concepts that you can use to implement split testing, and SageMaker makes it super easy to do that. And so from those versions, the model versions, you can create weighted production variants. So production variants are instances of the different model versions, and they're weighted based on how much traffic you wanna load balance to those production variants. You combine these production variants to create an endpoint configuration. And once you have that endpoint configuration, then you can create an endpoint from one endpoint configuration, and one click or one API call, and you create the inference endpoint, and that actually implements an API endpoint for your model deployment. So split testing made super easy with Amazon SageMaker as well. And so we now come back to the question about why use SageMaker for running TensorFlow. A lot of our customers have been running TensorFlow on EC2 for a long time, even before we launched Amazon SageMaker. And so I wanna highlight some of the features that make it super easy and super fast to implement your training and inference. And so we saw a lot of those features already, where you have access to all the GPU instances. You have access to pre-provisioned notebooks. You don't have to worry about managing any kind of infrastructure, and it makes it super easy for you to deploy and do iteration of your machine learning models, right? Throughout the life cycle of the machine learning life cycle, if you're using Amazon SageMaker, you don't really have to worry about managing any kind of infrastructure. You don't have to worry about maintaining and patching operating systems. You don't have to worry about maintaining and patching and upgrading deep learning frameworks. And you don't have to worry about logging and monitoring. All of that is provided out of the box with Amazon SageMaker. So if we dive into the training piece of it, right? One of the drawbacks of using services like SageMaker is that, yes, it makes it super easy for you to deploy a whole cluster of training instances and trains super quick. But it does slow you down during the development and testing phases of it. If you're debugging your code and you have to go in and create a whole cluster to test your code, it makes your debugging cycle very, very slow. So we have already solved this within SageMaker. It provides you with the capability to test your code locally on your laptop, or you can test on the notebook instances as well. It gives you access to the best hardware for training as well as inference with the newer P3 instances, the GPU-based instances within EC2. So you have access to the best hardware from SageMaker. And then lastly, it's super easy to go distributed. With one line of code, you can say, hey, I want these many instances for my training job, and you can go ahead and run a distributed training job as well. When we talk about model tuning, and this is something that I mentioned before, that comes part of Amazon SageMaker, people spend a lot of time experimenting with the different values of hyperparameters. SageMaker provides you with hyperparameter optimization that uses a Bayesian optimization and treats it as a machine learning problem. And so some of the common hyperparameters for most of the common algorithms are supported within this feature, and it will and you give us ranges, and it will find the best set of hyperparameters for your use case. So truly a really good feature for accelerating your development experimentation part of your cycle. Again, the hosting service is one call to the API, and it creates a fully managed scalable API for you that's highly available. The most widely used SDK that we offer is the Python SDK, and within that, all you do is SageMaker.deploy, call the SageMaker.deploy method. Again, the management of infrastructure is also taken care of by the SageMaker service for model hosting as well. We provide auto scaling is integrated within SageMaker, so you can define your endpoint can scale based on the load that you have. And so now it's time to get into the demo. So I hope I'll get enough time to go in and explain the various pieces. So let's start off with the Amazon SageMaker dashboard, and here's the dashboard. And you can see that here are the different aspects of the SageMaker lifecycle. The notebook instances, I can see here I have a bunch of these notebook instances. I can look at my training jobs, and so this is the training job that I launched a few minutes ago. right? And so let's go back to our notebook instances and let's open this up. So hang on, so I already actually have this one opened up. And so over here, and so we see that it got deployed. And so let's start from the beginning over here and see what we're trying to do. And so what we're trying to do is we're trying to train a model that can classify and predict this species of the iris flower. So there are three species that you can see here. And we're trying to predict which species it is by just looking at the dimensions of the petal and the sepal, right? And so this is how the training data looks like. And so we have the length and width of the sepal, we have the length and width of the petal, and then this is our label or the species. The three species are represented by 0, 1, and 2. And once we are done training, during the inference, we will be provided these 4 values, and we're gonna try and predict the species, right? If you look at it, there are 120 samples in the training bit and 30 samples in the test section of the training data. And so first and foremost, what I'm doing is I've already created an S3 bucket and gave access to that S3 bucket to SageMaker. So SageMaker can access it. That's something that that is done during the creation of the Jupyter notebook. And so that's something that I've already set up. And so this is my S3 bucket. And I'm specifying that my custom code should be uploaded to this folder. Secondly, I'm also specifying a different location within the same bucket for my model artifacts. Next, I get the execution role. The IAM role is something that needs to be created as well. And that is created also when you create the instance notebook, the notebook instance rather. And so when we move on to the actual code itself, so as you go through these samples, so let me actually go back and show you where the samples are located. So if I open this up, from the console, I can click the open button and go to the Jupyter notebook. And here I'll see that's the typical Jupyter notebook, except it's a little bit customized, right? So if you go into SageMaker examples, which is the customized bit, you'll see all the examples that we have out there. And I've gone in and I chose this one, the TensorFlow Iris DNN classifier using estimators, and you can click the use button and it'll prompt you where you want to copy this notebook. So I've already copied this in the interest of time. So if I go back over here, I can see this this folder over here, and this is the notebook that I'm using. So I already have this open. And within the notebook, it's within the same folder, you'll see this Python script as well that actually implements the custom code. And let's look at that. So if I run this cell, I can cat the Python code. And here's sort of the standard stuff that you'd have to implement as if you're using TensorFlow on SageMaker. It's expecting you to implement these 4 functions over here. First of all is it's expecting that this estimator underscore fn function needs to be implemented, and it needs to return this estimator object. And so this estimator object is created using 4 parameters. The first one is the feature column. First, we have defined that we've created the feature columns, and we've given it a shape of 4. Since if we go back and look at our data set, we have 4 columns, so 4 features that are going to come in, and we're going to be predicting this species over here, right? And so we're specifying the feature columns and specifying that the shape is 4. Next, we say that I want this is going to be a deep neural network. So deep neural network classifier. So I want 3 hidden layers, and the 3 hidden layers will have 10, 20, and 10 neurons respectively. Finally, I'm also specifying that there are going to be 3 output classes, since there are 3 species that I'm trying to classify. So next one is going to be our input function. So we have defined the estimator, we are returning the estimator. Now we have to define how TensorFlow gets the data, right? And so the first one here is this. So let's look at these 2 first. So the first one over here is the train input function, where we're loading the training data. And we're giving it to TensorFlow. Secondly, this is the function that SageMaker is going to call during the training. A similar function is the evaluation. And so as we split the training data into training and evaluation data, and here's the test or the evaluation data that we're loading within this function. And both of these functions are calling this generate input function. But essentially what we need to implement here are these 4 functions. Specifying the estimator, how to construct our neural network, and also specifying how to get the input for various phases within our training and deployment. The last one that I should mention is the serving input FN. Here we're specifying, once the model is deployed, how the model is going to get the inputs. All right. So, and if you go through this notebook on your own, and it's as you can see, it's highly descriptive, so you can read through all the explanations here. And so the next part that I'm doing is running this. I'm creating an estimator. So I import this TensorFlow class from the SageMaker SDK. And I'm creating this estimator. And the estimator, within the estimator, I'm specifying my Python script that exists over here that we just went over, that this is the entry point, specifying the IAM role, my output location from S3, and these many instances. These are the number of instances I want for my training, and this is the type of instance that I want. And my training and evaluation steps. So I run that, and then I create the estimator. And once I specify the location of my data, I can call the fit function over here that actually launches the training. And as you can see, it took a while, but it finished training. So you can scroll all the way down, and it'll tell you exactly how many seconds it ran for, right? And so one thing I should mention, one of the major advantages of using SageMaker is the cost that you're going to, the cost savings that you're going to have with using this service. If you were to do a deep learning AMI directly on EC2, you call the training, and the training maybe takes a few hours, and you come back. Now, the time between when the training finished and when you actually turn the instance off, you're paying for that instance, right? And with a service like a SageMaker, you really remove that. It actually charges you by the second for only the time that your training job is running. And so it's really it really saves you a lot of money from that perspective. Once I'm done training, then it's just a simple one-liner to launch my deployment phase, and it'll take maybe a few minutes to go and launch this. So as we saw, again we're specifying the instance count and the instance type, and once it's done, it'll show you how much time it took. And now we should be able to actually go ahead and test out our instance. So let's see. So here we see how we expected with these values, with these 4 features, we expected the label to be 1. And if you see the label is being classified, so there are 3 different outputs for our classifier, and the label 1 has the highest confidence score. All right. And so let's go on. And so I've already gone through and explained the iris data set, and we also went through the deployment phase as well. So in summary, here's what we went over, right? SageMaker completely supports TensorFlow, and you get a fully provisioned Jupyter notebook where you can run and build your training model and your custom code. You should definitely look at the built-in algorithms that are available within SageMaker, so you don't even have to write a lot of custom code. Once you're done building, it provides you with a fully managed, scalable training service. Same with hosting as well, along with auto scaling, and the whole life cycle. And this is a super important point. The whole life cycle can be scripted. So the life cycle can be automated. And so one of the other things that I haven't mentioned before is you can, if you already have TensorFlow code implemented and you don't want to change it to conform to the way SageMaker APIs or SageMaker SDKs allow you to be, so that you can bring in your custom code and also compose your own custom containers and give SageMaker those your custom containers for training as well. And lastly, we demoed a complete example of TensorFlow coding, training, and model hosting as well. The last point that I have is how to get started. It's super easy to get started. Here are a few resources. So we offer SageMaker as a free tier. There's abundant documentation online. All the sample notebooks are included in your notebook instance, as well as you can find them on GitHub. There is a machine learning blog that you can follow as well. and also look at our repo on GitHub as well for SageMaker TensorFlow containers as well. And so if you want to take a picture of this, these are some of the resources. And finally, we will take any questions that you might have.